Hi, this is Elvin Haag from AL 3D Print, and then with the second part of my re-review of the Sidewinder X1, which I do have a lot of years here, and you can also find my first review and my first modifications of this earlier in the videos on my site, and of course the earlier video here on YouTube or on my site and my Patreon, which has also extra files you can then download if you register and help me to get some coffee. In this review I will go further into the modification I did also with the EQ systems that maintain the Pi for working when power outages are, and also the printer, because it then runs on 24 volts. So I showed you this later. So first look at my earlier videos and then you can continue here. Thank you. The charger is a 24 volt charger of a scootmobile originally, and I use it for charging these two batteries, which are in series and therefore deliver 24 volts. And that means whenever there's a power surge, power problems, the printer will just continue working on 24 volt battery system. Like you see at this moment, they're not all connected because I'm doing maintenance. There's also some place for buck regulators and boost regulators, like you see here. And an extra switch here to make the connection between the printer and the 24 volt system by hand. And like you see here, there's another boost converter just in use to make the printer work whenever the battery voltage is going lower, and then the printer will still get its 24 volt. Since now we got more stable electricity than a couple of years ago here, some new cables were laid in the village, then now I will probably just let it go lower when the batteries go lower, so I don't need all this boost and buck regulators anymore, because of course they got old, and the capacitors of course, and they don't work 100% anymore, and as you see some cables are going to get broken and things like that, so I need to replace things. So we'll simplify it and also put an extra Wi-Fi connector between it. Like it is now here, I got a little flip-flop connector in it, so it's after the power is on, the relay will switch on. Here you see the relay for the printer for 24 volt. This relay will switch on and keep the printer running all the time until I depress this little switch in here, and then so that has to be manual done after 240 volt is disconnected already. So I got a Wi-Fi switch that is making 224 volts, and I got a Wi-Fi switch in the make that will work on the 5 volt or volt signal to disconnect the 24 volt power. So I can remotely turn it on and turn it off. As you see here, also on this side, the stabilizer. And normally this wire here is connected to there, so that this will be springy and moving all the time with the movement and keeping the wire away. Here we got the other side of the view of the case, and you also see this extra ventilation option for the printer mainboard, because this mainboard tends to heat up pretty fast, so I changed the ventilating as well. Actually I changed the ventilator in the main housing as well, to that it will only turn on when there's heating going on, so when it's really printing. And of course that can be done with only the heater element, the MOSFET going to the heater element of the print head. So that will make sure it will not be blowing and making noise all the time when it's not needed. I mean, when it's just standing by doing nothing, the mainboard is not getting hot. Especially since I got the external MOSFET also for the bed heating, so that can be on and no problem if it's preheating. I still preheat like half an hour before I start to print with this printer, like it's really needed. I didn't show you all the LED lights I got here. Got a lot of extra LED ribbon to have a good view with the camera and also have a good view myself, because it's normally in a dark enclosure. So the light is only coming from the printer, and of course for the 24 volt system you got. So now we will do some repairs, some rework on it. I like the printer, it still gives good results. Like I said, fast. I showed some other movies of it already, here on YouTube especially also. To show you the speed of this machine, it really goes really fast. If you make a print and you go like half an hour, and then you can have a roll of bed G already gone. 1 kilo is just printed, so it can be pretty fast if you want, if you need big prints. Of course then the quality is a bit less because you go fast, but it's still possible. So here is a schematic that I about to use, so I try to zoom in a bit and get you a bit better view. So of course you got the different AccuPacks, PSUs and charger. So let's first start with the simply part. So that's of course a bed heater. Here you see I got the MOSFET switch here, simply drawn. Of course it's a whole board and things like that with optocouplers. So bed heater is just cross directly of the 24 volts, or maybe about 28 volts of the charger that the batteries will have. When they are fully charged, they will be about 29, 28 volts, 28.7 volt, depending of the state of charge. And so that is here directly across the bed, so the bed will be heating pretty fast. Here you have the batteries, of course always they're about 24 volts. When the power is going lower, then of course now the so if the 20 volt power is off, then the battery will discharge and therefore give a lower voltage. So keep that in mind. So it will be first 24 volt and later it will be dropping maybe to 22 volts, depending on how much load there is. So therefore I first had this buck and boost converters between it, so that the printer at least could get still the 28 volts, even if the power of the batteries was getting lower. So now it's like, okay, it's dropping, no problem, until the power comes on then. So here you have the PSU of the printer itself. It gives, when you turn it on, 20 volt to the, of course, to the whole printer and also out. I use a smart switch feed there, or just a normal switch to turn this connection off, but normally it will be on. So that means that when it turns on, there will be voltage going through here, going to the through this kill switch, powering this relay here, and therefore getting the whole 24 volts of the batteries going through this little diode and going back, and therefore making sure that when the voltage is lower than it should be, at that time the batteries will discharge over the whole printer and therefore keeping it on. And normally after it's turned on, there is a short connection here, of course, like you see. So this goes to here, this goes to there, and directly also to the kill switch. So as long as I don't use a kill switch, the printer will be powered from the batteries in all times. So it will mean also with the battery charger for these batteries. So that is the simply system to keep it running at all times, even when the power goes off. And of course, this is extra important for the Pi. That is powered from there. So there is the Pi and the webcam. That's powered from a little buck regulator, which you saw in the little box, the little black box that's there. And that is just powering from the 24 volts of the whole system is powering the 5 volt for the Pi and the webcam. So quite easy. Only when the power goes off, then it will be powered from the battery. When the power is coming on again, then it will be powered from the printer and from the battery charger, of course. And only when I'm done using the printer and the Pi, so when I have shut down the Pi and Octoprint, then of course I use a kill switch after that, or after the 224 volts is already off. Use a kill switch shortly to disconnect this relay, and therefore it will just disconnect, and so the printer will have 0 voltage again. So I just put it back on, and after I will remotely turn the printer back on again with the 220 volt. It will start and then recycling again. So it will be possible to remotely start but not remotely close it off. So here you see the external MOSFET doing its job when the printer has been preheated. So, and here I got the multimeter connected. Let's get it into vision. So when I look now, then as you see it bounces a lot up and down because it's turning on and off very rapidly, just like the schematic of the printer's software is setting, the firmware, to keep a steady temperature of the bed, and of course it's now for the extra bed. As you can see now, there's about 29 volts getting on the charger, so it means that it's almost fully charged, and so for us it will go down. And of course when I turn the bed heater on a high temperature for the bed, it will turn on steadily, and you will see that is putting like 25 volts to the heat bed, and of course that the battery voltage is going down as well. So this is like steadily, and of course when it's on temperature it will start going down again. So this is just the 24 bed heater that is extra connected to it to keep it on top. So I'll show you around on this printer. So you got this extra cable that's going directly to the batteries, as you see down there, just for the bed heater, and here this is the cable going to the relay and the batteries as well, for this keeping voltage on. So when I take the cable off the printer or turn it off, so now everything stays on working, including all this LED lights. These are on the 12 volt buck converter, because now it's running totally on batteries. And as you see, the temperature is still high. So now only the 24 bed is heating, and since the thermistor is in the lower bed, the original bed, it will not hold up, although the top bed is really on temperature, so the print will not release. That's a good thing, but after a while, of course, the printer will give an error because it has too low temperature for the predicting. But nowadays we only have short power outages normally, not like 5 minutes or 20 minutes like a year ago. So only a couple of times a day normally, short low power or off power on the grid here in this village, depending also on tourists. So now the heater is on all the time. The 24 volt heater is on. I don't think you can see it from here. And of course the temperature that is listed is going down slowly. It will be only minutes. Like you see it going down, 75 out of 80. As you can see, it keeps heating. Power is going down, 23 volts on the batteries. So it will maintain a lot of time, so it will be not such a big problem. Now the volt is already going down to 22. I don't know if you can see it on this camera. Of course it's now powering the whole printer, inclusive the LEDs, but not the heater for the hot end at this time, since it's not really printing, just preheating. And of course the Pi is also powered by batteries.